All right. Ladies and gentlemen, another way of actually using percent in real life is to using them when you shop. When you shop, we're talking about discount, we're talking about sales, we're talking about markup. That's not all. Whenever you are buying something, you're paying taxes. When you get older, you're also gonna pay taxes from your income. That's called income tax. And when you have some money and you deal with banks, you will have to either pay or earn interest. The next problems will actually have to do with all of those applications. So let's go to page number 11 of your packet. And we can start with first problem. Right here, Ben earns $12,800 a year. About 15% is taken out for taxes. How much is taken out for taxes? That is the question. So, since we are talking about a salary, we know that the taxes are taken out from the salary. Therefore, we are looking for the 15% of 2,800, and that will be the part that will be taken out. So let's set it up. To set this up, we're gonna use our similar formula, which is over of percent over 100. So we know that we're looking for 15%. We know also that we're looking for 15% of 2,800, 12,800, I'm sorry. So right here will be an X. When we cross multiply, we are going to find out that this is, let me just do it for you quickly. The taxes are equal $1,920. That's how we find our taxes. Ladies and gentlemen, let's go to problem number 2 on that page. At a sale, shirts were sold for $15 each. This price was 80% of their original price. What was the original price? Right here, we're looking for the original price. So once again, using the same formula, is over of percent over 100. We can fill that in. 80 goes on top of 100 because that's where our percent goes. And then we are looking for the original price. Original price, or the price at the beginning, is always the price that goes right here on the bottom, which means we don't have it, it will be X. But what we do know that the 80% is worth $15. Right here, ladies and gentlemen, we're also going to cross multiply, and we are going to find out our original price. So give me a second. After you cross multiply, you will know that our original price equals $18.75. Problem number 3. Problem number 3 is actually very similar to problem number 2. Let's read this together. Skylar bought an electric drill at 85% of the regular price. She paid $102 for the drill. What was the regular price? Just like before, we are going to use the formula, and since we already know that it's pretty much the same type of problem, we know we're looking for regular price, which will put X right in this place. We know she spent 85%. She paid 85% of the original price, and then she spent $102. When cross multiplying, ladies and gentlemen, we are going to get X equals $120. Okay. Hold on a second, let me just see. Let's do some sales. 390 is on sale. Okay, here we go. Right now, let's go to question number 5. A shirt that's regularly sells for $38.50 is on sale for 25% off. The question is, by how much money is the shirt being discounted? What we're looking for right now is 25% of that price. 25% of that price, again, looking the same, using the same exactly formula, will be $38.50 right here, 25% and X. When we find the X, we are finding the amount of money that the shirt is being discounted by. So we multiply across 38.5 times 25 and divide by 100. So the amount of discount, X, will equal, in our case right now, $9.63. Okay. All right, David. Let's find the sales tax. Let's do a sales tax. Okay. And you'll be kind enough to cut those out, yeah? Thank you. All right. Let's go to problem number 6. If you purchase an iPad that costs $339, how much sales tax will you pay if the rate is 8.375%? Once again, what we're going to do is to set up the same exact formula where we put 8.375. Right here on the bottom, we will put our original price of the iPad, which is $339, and this is X. We have to cross multiply. 339 times 8.375 and divide that by 100. And the amount of tax that we are going to have to pay is equal to $28.39. Beautiful. Mm-hmm. Okay. Let's move on to page number 12 and question number 11. Here we have to deal with markup. Markup is when a seller makes the price higher. In order to make a profit, they have to sell it to you for a higher price. So this way, they can function in their business. So let's start. What is the retail price? Cost of an oil change is $18, and the markup is 70%. What we're looking for is going to be the same exact formula, which will be 70% of 18. And we are going to find what that is by cross multiplying. 18 times 70 divided by 100, which in our case is $12.60. However, that is not the end of the problem. What we have to do with it is to add this markup to the original price. Then we will have the retail price at the end. So what we're looking for is to add 12.6 to $18. This way, our answer to the following problem is $20.60. That is the price, that includes cost and the markup. Okay. Okay, page problem 14. Now, let's go to problem number 14. Here we have an example of a discount. what is the price you pay when original price of concert tickets is $100 and the discount is 21%? Once again, using the same exact formula, we're looking for 21% of $100 equals X. When cross-multiplying, we know that X will equal 21. Now, that is our discount. However, that is not the answer yet. The difficulty of solving the problems here is not calculating the numbers. The difficulty is actually in reading what we're looking for. Right now, we're looking for the price that we pay. Well, price that we pay is after the discount. Therefore, we have to subtract 100 minus the 21, which equals 79. And that is the correct price you pay. We good? I think we're gonna just move on to the next one. What do we have next? Are you spacing out here?
No, a little bit, but I got my control.
Clouding, an umbrella. Hold on a second. There is one thing that I want to do. No. One more thing. No. Okay, I don't know what it is. Okay. Good. All right. Now let's talk about simple interest. Interest is when you go to the bank and you deposit your money, and after some time, bank gives you your money back as well as extra money on top of that. Or if you go to the bank and you try to borrow money from the bank will give you the loan, but then you have to pay that loan and some money on top of that. That's what interest is. In our case, we are going to be learning about a concept called the simple interest. The actual introduction to the real world banking. Ladies and gentlemen, before we start, we need to talk about all of the components of simple interest. Well, right here, we are going to use the following formula. I equals PRT, where I is the interest, amount of interest, meaning the actual dollars, the amount of dollars that you're either gonna pay or you will be paid, depending on whether you deposit or borrowed. The P stands for principal, which is the money at the beginning, whether you're borrowing or depositing your money. That is the amount of money that you're doing. It's called principal. R stands for interest rate. Our interest rate could be 3%, could be 5%. However, it doesn't matter what the percentage is, it matters that you're gonna be writing it as a decimal. And then T, number of years. That's very important. Like if you have 2 years, that means T will be 2. But if you have 6 months, then the number of years will be actually 1/2. Please keep that in mind when reading the questions. And the money that you get at the end, is called balance, where you add your principal and your interest together. Let's go and solve a few problems. Right here we have first example. In the first example, we are looking for I, which is looking for interest. The best way to do it is to write yourself the formula. I equals PRT. And right here, note all of the numbers. I, P, R, T. Let's read this together. What is the interest earned on $350 invested 4 years at 5% simple interest? Well, let's put this all together and see. I'm looking for interest. Well, right here you can say what is the interest earned. If it's what is, therefore I don't know what it is, I'm gonna put this as an X, because we don't know. That's what we're looking for. Next, our principal, ladies and gentlemen, is the money at the beginning that I invested. Well, I invested here $350. My rate is 5%, but as I mentioned this before, you have to write it as a decimal. Therefore, it's going to be 0.05, and our T is 4. Once you have everything set up this way, you put this all together, you plug those numbers in. So in our case, x will equal 350 times 0.05 times 4. You can use your calculator later on to quickly find the answer. And our interest will equal 70. That is the amount of interest that you will earn given your rate at 5% and 4 years period. Now, ladies and gentlemen, let's go to the next one. Hold on a second, David. I just need to adjust this. Ladies and gentlemen, next example. If I put $1,500 into my savings account and earned $180 of interest at 4%, simple interest, how long was my money in the bank? Once again, we're going to use the same formula. I equals P R T. And then we are going to find out all of the numbers. So, if I put $1,500 into my savings account, therefore $1,500 is the money at the beginning because that's what I'm going to put, goes as a principal. And I'm going to earn $180. The money that is going to be earned on that principal, it is my interest, 180. My interest rate right here is 4%, which means I'm going to write it as 0.04. And what I'm looking for is my x. Let's plug those numbers in and see what happens. 180 equals 1,500 times 0.04 times x. I'm going to multiply 1,500 and 0.04 first. And I get 180 equals 60x. What we have here is one-step equation. As you all know, all you need to do right now is to divide by the number that's next to x. In our case, 60. If I divide both sides by 60, I'm going to get x on the right side and 3 on the left side. Therefore, our answer is 3 years. That's the amount of time that we're going to need. Got it? Okay. The next example, ladies and gentlemen, is about balance. What would my final balance be if I put $650 in the bank for 60 months with an interest rate of 6%? Let's start this together. I equals P R T. However, we do have to include the next formula, which is balance equals P plus I. So let's start. I, P, R, T. Let's see what we have, what we don't have. By looking at it again, I see that my principal is 650. And I see that my time is 60 months. However, here you have to remember to change those months into years. Well, 60 months equals 5 years. So I'm going to put 5 right here. And my interest rate is 6%. And I'm going to write it as a decimal, which is 0.06. When I put this all together, I see that I don't have interest. And in my formula for balance, I need my principal, which I already have, and interest, which I don't have. So let's find what that interest is. So my x will equal 650 times 0.06 times 5. my interest will equal $195. Now that is not the end. We need to take this $195 and add to our principal. If you add $195 to 650, you will get $845, and that is our answer. Okay? Oh, this is awesome. All right, ladies and gentlemen, the last problem among our examples is problem that we're going to look for rate, the rate of return. My final balance after 48 months was $896. If I originally put $800 into the bank, what was my interest rate? Let's start this again. We're going to write I equals P R T. I P R T. And also we're going to write this for balance equals P plus I. So let's look for it. I'm looking for interest. My final balance after 48 months was $896. I put $800. I don't have the interest. However, what I do have is my final balance, which is $896. And I know that my final balance is my principal, which is 800 plus I. Well, the difference between 800 and 896 is $96, and that is my interest, $96. Now I'm looking for the principal, which we already have right here as 800. And what else we have? We have 48 months. Once again, we need to change months into years, and 48 months equals 4 years. We're looking for the interest rate, which will be X. Let's plug these things all together. My interest, which is 96, will equal principal 800 times X times 4. We can multiply 800 and 4 together, and we're going to have 96 equals 3200 X. And now we have one-step equation in which we'll have to divide by the numbers that's next to an X, which is 3200 here. When you do that, you will find out that 96 divided by 3200 equals 0.03. That is your answer. However, if I ask you to give me percentage, you have to move this decimal twice to the right side. In our case, 3% is our rate. Good. Awesome. Are you learning something, or you're just...
Oh, just relearning.
Okay. All right. Perfect. Let's okay, simple. Sure. You're already going anyway. What do we have? What is left? Oh, I got it. Here we go. The last thing is right here. Is percent error. Ready? And actually, this will be the end, because we're going to go over a couple of those examples, and we're good to go. I have to go too, because it's good. All right. Before we do that, ladies and gentlemen, let's talk about the last thing in our packet, which is percent error. In real life, if you're working as an engineer, you will find out that what you expect, if you design something, certain elements that you design, what you expect them to be and what they really are can be a little different. Not much, hopefully, but can be a little different. And so you're gonna find out exactly how much different they are, and you're gonna express it as a percent error. If your elements are within the specifications within the tolerances, then you will be good to go. But if they're not, you will have to redo this entire process again. But we're actually using 7th grade math in order to do that, which is pretty cool. All right, so ladies and gentlemen, the formulas are written on the board, which are estimated, whatever you estimate, minus actual over actual, or if you do experiment versus whatever it's accepted, like let's say you're boiling water and you're checking the temperature of boiling water, which is 100 degrees Celsius, that will be the accepted one. But in your case, the temperature is 104 degrees Celsius. There's a difference, and so that will be your experimental. So you're gonna have a percent error. Ladies and gentlemen, it's very similar to our percent change. However, in our case, we always have to put this in absolute value. Absolute value makes sure that no matter what the percent error is, it is always expressed as a positive value. Let's start to look at the problems here. Sit down so you're not going to hear. All right. Okay, let's talk about percent error. The first problem. Jessie estimates the weight of her cat to be 10 pounds. The actual weight of the cat is 13.75 pounds. Find the percent error. Well, you have two numbers. First is 10 pounds, and second one is 13.75 pounds. Let's look at this closely. Now, if Jessie estimates that her cat weighs 10 pounds, that's our estimate. Now, but the actual weight, when Jessie actually checked what her cat is weighing, she found out that it's 13.75 pounds. So that's our actual value. Once you have those numbers, everything else is pretty simple. You're going to build your percent error like this. Your estimated goes first, minus your actual, divided by your actual. Then you need to make sure there is absolute value. So no matter whether it's positive or negative, it's always going to show up as positive. And you're going to multiply by 100%. So let me see real quick what we got here. 10 minus 13.75 equals 3.75 divided by 13.75 times 100 equals 27.27 repeating percent. Ladies and gentlemen, that's a pretty big error. 27%, not really anything small that we can accept. Let's do next one. Each week, Mr. Jones goes to the grocery store. Mr. Jones estimates, again, the word estimates points out what we're looking for, that he will spend $120. So let's assume that this is our estimate. When he goes to the grocery store, he actually spends $94. So that's his actual spending. Find the percent error. Let's put this all together. His estimated is 120, that goes first, minus 94 over 94, and then times 100%. You will subtract 94 from 120, you'll get 26, divided by 94 times 100, and his estimate, his percent error is 27.65. Okay, let's move. What is going on? Why is this not moving together? Hold on. Oh, here we go. Let's go to problem number 4 on the same page. Eva estimates that 475 songs will fit on her MP3 player. The actual amount of songs that fit is 380. Find the percent error. Here, please pause for a second and solve it by yourself. When you finish it, press play again and see if you can get the same answer. Okay, let's find if your answer is the same like mine. Eva estimates that there are 475 songs, so that's the number that she's going to estimate. But the actual number of songs is 380. And once again, we're going to set up our estimated, which is 475 minus 380 over 380 and times 100. $475 minus 380 equals 95 divided by 380 times 100 equals 25%. I guess Eva was quite optimistic about her MP3 player. I hope you got the same answer. All right. Oh, not this way. Let's go next one. Let's do problem number 10. Jillian calculates to see if it will take 95 minutes to run 7 miles. She runs the distance in 80 minutes. What is Julian's percent error? So here, hold on a second, just pause here a moment because this is question accepted. Calculates, estimates. Okay. Once again, okay, got it out. Ladies and gentlemen, let's go to problem number 10. Julian calculates to see if it will take 95 minutes to run 7 miles. She runs the distance in 80 minutes. What is Julian's percent error? Please pause it for a moment, solve it, and then come back to press play when you're done and see if you can get the same answer. Let's see if you got the same answer like mine. First thing, we need to find out all the numbers. Well, she's gonna run 7 miles. She thinks she's gonna run in 95 minutes. So that's what she estimates. Now, she actually runs that same distance in 80 minutes. So that's your actual value. Ladies and gentlemen, let's set this up again. Your estimated, which is 95, minus 80, which is your actual, over 80, times 100.